Hi, welcome back to my YouTube channel, the place where I talk about things that I find interesting while hoping you'd feel the same. Today we're taking a look at the software that is running on Raspberry Pi, that is the heart of my little home automation AI GLaDOS here. We're taking a look how voice assistant AIs work in general and how my implementation of it works. I like the convenience of having a voice control AI at my home, but I dislike Google and Amazon and other black box AIs that I have no idea what they... Cancel.
Sorry, I thought you were talking to me.
So I decided to create my own from scratch. At least that way I know what the code is doing. This is the third and last episode of the GLaDOS Voice Assistant series. If you haven't seen the intro or the hardware introduction, check out the link somewhere there, and both videos are linked in the doobly-doo.
The software overview.
AI Voice Assistant consists of 4 different modules. First part of the chain here is the wake word detection algorithm, which is constantly listening to the input from the microphone and trying to determine if the wake word was in the input or not. If the wake word detector algorithm figures out that you just said the trigger word, it triggers the next step in the chain, which is the speech recognition part. The computer starts listening to the input from the microphone, records it, and ironically enough, it sends it to Google for speech-to-text recognition. After we have the text version of the command you just gave to the system, it's passed on to the natural language processing and skills part of the code. It processes all the input into response and does all the actions you need. Currently it's just a big bunch of if and else statements after one another, but I'm planning to change that into a AI chatbot algorithm. That way it can try to figure out from the context what you probably meant instead of did you mean this exactly? And that makes the whole algorithm a bit more robust and work better. Currently it needs an exact input in order to trigger the if and else statement. After the actions have been processed in the natural language processing and skills section, the output from there will be shoved into a text-to-speech engine that generates the GLaDOS voice and output of the system, aka make the device talk to you.
If you want a joke, you should look in the mirror.
And this is basically an AI voice assistant in a nutshell. For those playing along with home, you can get my code from GitHub under my nickname Nerdaxic and a project called GLaDOS Voice Assistant. It's mostly written in Python and it should be rather readable. As hardware, I'm using Raspberry Pi 4 with basic power supply and 64GB card. And here you can see some other miscellaneous hardware that's moving the eye and whatnot. For that, check out my hardware overview video.
The voice assistant functionality.
Currently the software can do basic things like the clock, it can control my lights and devices, it can tell me the weather here and the forecast for the next week, it can add things to my shopping list, it can read sensor information from my home assistant. It can give me random 8-ball answers if I ask it questions like should the person watching the YouTube video subscribe to my channel?
Ask me again in a few decades.
And it can tell me jokes, it can be judge and it can be mean, and it has some advanced fat shaming in there. I also have some code to log stuff and gather some training data for the AI for the further development. But this is done locally, so if you run this, I won't get your data.
The main program structure.
The main part of the voice assistant is a Python script called GLaDOS.py. It resides in the GLaDOS Voice Assistant folder. And that is something you can actually run with cron tab whenever your Raspberry Pi starts. It makes it a lot easier to just have it go whenever you plug it in, basically. Let's dive deeper into the master file, GLaDOS.py. This is a Python script that first of all imports all the other files. Here are GLaDOS text-to-speech engine. There's the GLaDOS time handling Python scripts. Then there's the home assistant scripts, serial communication scripts, servo controller scripts. The key for the trigger word detection is a library called pocketsphinx. It uses functionality called LiveSpeech from there and the speech recognition. And those two are used to figure out whether you called for the assistant or not. Then it uses some other basic Python libraries. I'm also loading some environment variables from the settings.env file, so this thing would be easier to deploy on different installations. And all the settings and whatnot are in one place, so you don't have to go edit million different files because of that. When you first start the voice assistant, it pops up behind the scenes sub-process GLaDOS Notify API. This is for the home assistant. This basically sets up a server running on the Raspberry Pi with this Python script. And the home assistant has API access to it. And the home assistant can then send notifications to this API and the robot will speak them. So it can give you notifications like the fridge is open or sauna is ready or whatever.
According to my sensors, somebody left the bloody fridge open again.
First thing after that is to set the eye animation to idle. So you can see the large yellow pixelated dot there. Then it sets the eye position to default, which is set up in the servo controller firmware. And then it sleeps for a second because that's just good code to make the user wait. Then there's a couple of options. I can either play a file from the audio directory, which is the wake up sound from Portal, but I use the text-to-speech engine to do that. So it actually animates the eye, opens and closing and moves it back and forth. We'll come to that later. But here the timings here were extracted from the game. And after it has gone through its, oh it's you, it's been a long time, how have you been? It sets the eye position to default and here we are running. Then I have an utility script here, restart program. It just kills the process and restarts it. It's handy when you're developing it. You can just ask it to restart instead of finding a command line window and killing the process and restarting it and then... Then we have the take command function, which is triggered when the trigger word is said. It shouldn't matter if you trigger it by a button press or a trigger word. It should still work the same. It will give you a command line notification that it's actually listening. Then it will play a random detection past sound. There are 20 different options and it will give you a random sound file from the folder. Then it initializes the recognizer. And listener uses my microphone as the source. This line here is for it to collect some ambient noise data if you have not so good microphone. I'm using a good microphone, so I have noticed that it works the best if I don't have this one turned on. After all this processing and speaking, like what do you want or something like that, it prints the speak on the command line. It turns the little dot next to the eye green. Then it starts recording whatever source you have selected, aka a microphone here. And it times out after 3 seconds. After that you should have your voice in this variable here. It gives you acknowledgement. It turns the eye back into idle, which is the red dot instead of green dot. and then it uses the listener library and shoves your voice data into a Google API, which is bad, but at least I'm deciding what to put in there. I still haven't come up with a better solution to do this locally. If you have any idea or you want to contribute to the project in GitHub, please do so. I want to get rid of this function here. But it works, and it gives me the text, what I just said. Then the command is turned into a lowercase and printed on the command line once again for easier debugging. Then I have a function here that can be used to save the voice sample, and you can use that in a long run after you have collected a lot of samples to train the speech-to-text recognition module. After that, we process the command a bit. This OS get environment variable trigger word. This is basically your trigger word. If the trigger word is in command, then replace the trigger word in the command with nothing. If you actually say the trigger word in the command, like twice, this thing removes it from there and ignores it. It makes it a bit more robust. Then the functionality returns the command you just said. Then there are some exceptions. For example, no speech was heard, then do this. And if the speech-to-text API has failed for some reason, then give some complaints about speech recognition core being offline. And if there's some other issue, you can add here your own request errors.
Natural language processing.
Then we have the actual fun part, the function process command that takes a command into it. And it's the long as if-else statement currently. Don't judge me. You have to start from somewhere. The most common thing I say to the robot is cancel, and that's just ignore whatever I just said. And if I do that, it will play a random, sorry about that, type of file. There's like 4 options currently in there. And then it will log what I just said. Then I have timer. It can start a timer. There's a separate Python file with the timer functionality that just can process the command further. But the command here can contain things like add a timer for pizza for 15 minutes. And it would be in text here, and the start timer function would process it. Then it will give you the sure and move on. It can give you the time. It will just read out time. Then there's the magic 8-ball thing. Should I, should the, or shoot the, because it's stupid voice recognition. If any of those are in the command, then play a random file from the magic 8-ball folder. Then there is if there's joke in the command, it plays a random file from the jokes folder. They get old real quick. If you have more lore-friendly jokes, please post them in the comments and I'll add them here. If there is something, my shopping list, something in the command, it will run the add to shopping list functionality. Who are you? It can give you intro audio. It's a one single file. What can you do? It's another file here. And then there's the weather. If you say today, it says the forecast from Home Assistant for the index of days 0, aka today. You could have like, say, forecast from Home Assistant 3, which would be like few days from now. If you ask for it the current weather, it will use a different function, and it will get that from my own weather station instead. So it's basically reading a sensor on my balcony. And same is like for the right now. And otherwise, you can ask it, for example, what's the weather like on Tuesday, and that will be in the command, and it will get the day index from that. If you say Tuesday, it will calculate how many days until Tuesday, and then it will say the forecast from Home Assistant with that day index. So it will respond to you with Tuesday's weather. So the robot cannot tell me what's the weather in Ibiza right now. Then just for fun, I added a random check that there's like 1 in 10 chance for it to say, you don't even care, do you? I have heard that once so far. Then I have some lighting control functions here. If I say something daylight, it will activate a scene from Home Assistant and turn on daylight in here. And then it will speak up that it can simulate daylight at all hours and add adrenal vapor to your oxygen supply, which is very GLaDOS thing to say. There's the studio lights that I have set up here. There's night lighting, which is also the same as turn down the lights. It will turn on the night lighting scene and comment something like acknowledged type of thing. There's also different ways of saying it. There's a night light, and it will give you a different spoken answer. Almost time for you to be detained in your relaxation vault. And the classic turn off all lights. It uses light group of all lights and turns it off. This is also a function that passes data to Home Assistant. Then there are a bit more, let's say, shaky commands. If I want to close anything in bedroom, it's probably gonna be curtains. So it will set bedroom covers to closed and acknowledge it, and open bedroom curtains and set them to open and acknowledge it. But then there are a bit more fancier commands, which are if you have blinds in the command or curtains in the command, this would trigger on both. If you want to open them, then run one of these. If you want to close them, run one of these. And then there's the room, bedroom or living room. And I have those IKEA roller blinds that are electric. So I can ask it to open living room curtains, and it will run through this, and it will run this one here, which calls Home Automation Service. It sets cover position in the cinema to 100% aka up. It opens my curtains with speech. Then there's like hallway lights, bathroom lights, the same logic. Then there are some device control functions. If I want to turn on my cinema, home cinema, then it will run a script that is saved on my Home Assistant server, which is currently käynnistä kotiteatteri, start my home cinema, which sets up lighting, it sets up the TV, all the devices on the right channels, closes the blinds, and it just turns this place into a cinema. And then it will give me this, okay, it will take a moment for all the devices to start. And same goes for the turn off command, turn off cinema, that is valid a command here. And it will just run the turn off script. There's functionality to control the air conditioning here. If there's air conditioning or AC in the command and I want to turn it on, it says give me a minute, makes a joke about neurotoxins, and then it calls a Home Assistant service called climate set temperature. This is my living room air conditioning unit. I want it to set the temperature to 23 degrees Celsius, which is hard coded here. If I tell the device to turn on air conditioning, it has to set it to something. I want to turn it to heat/cool, so it decides automatically whether it needs to cool or heat in order to get to 23. And then I want the fan mode to be auto. So it basically sets my air conditioning to normalize the room temperature if I give it this command. And the same goes if I have AC turn off. It will send the turn off signal to the living room AC. Then it will complain about the neurotoxin levels that will reach dangerously unlethal levels within a minute. Then there's some sensor input. You can read the living room temperature. I can't just read numeric data from Home Assistant. Bedroom temperature, the same thing. If the bedroom temperature is hotter than 23 degrees Celsius, it will also comment that it's too high for optimal relaxation experience, because it for goddamn is. Then it can get my outside temperature from my own weather station. I'm Finnish, so I have sauna, so I call it incinerator. It gets the number value of the sauna, stores it in a variable, and if it's over 55 degrees, then the sauna is ready. You can get in there, and it will tell you that the Aperture Science Emergency Intelligence Incinerator preheating cycle is complete, and you should be baked, and then there will be cake. But if it's not ready, if it's under 23 degrees, aka normal room temperature, a bit high normal room temperature, aka the sauna is off, the incinerator is currently offline. And if the temperature is larger than 23 degrees, then it will give me it's currently heating, preheating cycle is currently running, and then it will run a function that will tell me when the sauna is ready. I know my sauna heats 3/8 of a degree Celsius per minute. So knowing the current time and the current temperature, I can calculate the time when my sauna is ready. Can't do that with a commercial voice assistant. This thing can. It's handy. Then there are some fallback things. I can get the average indoor temperature and average indoor humidity by just asking them. Then there are the pleasantries. How are you? It can answer to those in a lore-friendly way. Can you hear me? Good morning. Of course, if you say good morning to it, it will actually check if it's morning and be mean if it's not. Do you even know what word morning means? Then I have a specialty function here to play a pink noise. It plays the pink noise sound file. If this is to calibrate your audio. So if you plug in a calibration microphone and measure the frequency response of your unit, and then figure out what do you need to change in the EQ to make it more correct, and then use the Altamix EQ to fix it. It makes the robot sound much more present and bigger. It's still not great, but it's much better than without it. So it's here. Please don't ask it to play pink noise if you're in my house. Because it's a voice-controlled computer, it should also have the shutdown and restart commands handy, because especially when developing, those are actually quite needed. It can give you a speech about murdering her and restarting. The cake and grief counseling will be available at the conclusion of the test. If it didn't catch anything intelligible from your command, you just fed it some garbage, it will set the eye animation to, I call it angry. It turns the eye basically red. It prints the command not recognized into the command line and plays a random, like, I have no idea what you just said type of audio. Then it will log it locally to failedcommands.txt, and this can be in the future used to add more functionality here. This is just my first set of these. I will be adding more here as I need them, and after I feel like I've done all I need, I will turn this into an AI-based chatbot algorithm, so it's not exact. This thing has to be in the command, but if this thing is the closest thing of the probabilities and that kind of stuff, it makes the speech recognition more it feels like it understands you better, let's say. After it has processed your command, it prints the waiting for trigger, sets the eye position to default again, and sets the eye to idle again. And we're ready to go again.
The trigger word detector.
How the actual trigger word detection works, there is basically a loop here. It uses the LiveSpeech library to look for your trigger word with this probability. And if it finds the trigger word in the phrase you just spoke for phrase in speech, it tries to listen for the command, take the command, then execute your command. There are multiple reasons why it could fail. Currently I'm handling them all as just one exception here. You need to write better code. This keyword detection loop here, this is all the functionality basically of the robot.
GLaDOS text-to-speech engine.
Here we have the GLaDOS TTS.py. There are quite a bit of libraries included here. It uses also the settings.environment file, and it has a single GPIO pin that can be used as a mute pin. This is connected to the enable pin of the amplifier, and the idea is that when it has to speak something, it turns on the amplifier and then speaks and then turns off the amplifier. That means that there's no noise coming out of it, and it saves a bit on electricity. Then there's the synth folder, which contains all the audio samples. It's also stored in the settings file. And the main functions here are just to play a file. Play a file in chunks from a file called file name using PyAudio. Stream it from there using sound card that has been determined in the settings. Read data and play it. After that, sleep for a tiny bit. Stop the stream and close the stream. I have no idea why this is needed here. It doesn't work without it. This thing made it work, so that's how it plays a audio file. Then there is a text parsing function. This function is used to clean up the text before being passed to the text-to-speech engine. So if you send the degree sign into the text-to-speech engine, it will always say degrees. And if you try to make it say sauna, it will always say incinerator. And everything will be always lowercase. The idea of this is to make the text-to-speech engine pronounce the units correctly, so it doesn't say, for example, the relative humidity percentage in a weird way. It just says %. You don't need the garbage the Home Assistant gives you. Then there is a similar function to process the file name. The file name structure is GLaDOS line TTS line. Then the command that you just said with all the spaces replaced with the dash, and some specialty characters replaced .wav written in the end. It just gives you a cleaned up file name basically. Then you have a function that checks if the text-to-speech library already has your line. If you do, it returns where it is and what the file name is. And if you don't, then it says false. Then there's the function to actually generate the text-to-speech sample. I'm using this GLaDOS voice generator that you can find in this URL. I'll also link this in the doobly-doo if you want to play with it. Please be gentle, because this thing takes quite a lot of time to generate a voice sample, as it's based on a female text-to-speech engine, but then goes through an automated Melodyne process, which has been built on, I think, AutoHotkey or something. So once you generate a sample, there is actual software robot going click, 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 click to make the voice sample happen. and it can take a few minutes to generate one. And this is why I'm caching the files locally. But if the check TTS library function figured out that you don't have the file, you have to generate it, it will use this. You can find this code in the end here. You're using curl function to get the line you're passing into the function to generate the voice line and save it into an audio file with the same name. This thing has a couple of options. If the sound sample is needed right now, for example, if you're asking what the weather is and the weather is cloudy and it has never been cloudy before, you kind of need that information before speaking it out. So the wait parameter here is automatically true, meaning that it will basically wait until you have the voice sample and saved. If you don't have the wait saved, then it pops up a sub-process to run the same thing, and this is useful when you, for example, add potatoes to your shopping list and it doesn't know what potatoes are. It will just say like whatever, sure, and run this instead. So it will generate the word potato in the background instead of holding the whole process. So next time you ask it to add potatoes to your shopping list, it can answer, okay, I added potatoes to your shopping list, because then it has the voice sample. Then there's the main speak functionality. If you write a piece of code, for example, to speak a line potato, it checks if the potato is shorter than 255 characters, aka it can fit into the API. It checks if the file exists already with the potato in it. If it does, then it checks if there is an I position script for that particular line. And if there is not, then position the I randomly. And for example,
oh, it's you. It's been a long time. How have you been?
There is handmade animation in the software and the firmware of the controller, and it can actually use that same animation always when you speak that specific line. Then it will play the line from the file and it will print it on the command line. If it doesn't know what potato is, it will print that file doesn't exist, it's generating it. It will play generic, hold on, this might take a while type of audio, and fetch the text-to-speech sample and then play it. That concludes my deep dive into how my GLaDOS Voice Assistant works. Hope you found my video about my craptastic code entertaining and somewhat enlightening or something. Check out the GitHub page for setup instructions. You can download the source code from there for free and try to modify for your own use. Feel free to fork it. It might change any minute I get around to doing some more coding to it. There are a bunch of libraries that you have to download to make this thing work. If you haven't already, check my intro video about the GLaDOS Voice Assistant and the hardware introduction, what's in the actual robot there. Anyway, thanks for watching and see you in the next video.